In the final analysis, belt tension is the key to proper functioning of the accessory belt drive system. Transferring torque to run the accessories is job one, and anything that interferes with that transfer is a problem. In the past, much of the focus of torque transfer failure has been on the belt itself when in fact, belt tension is the culprit. In the next few minutes, we'll explore the role of belt slip, misalignment, failure of the tension damper, belt pulley contact, and tensioner wear as key failure modes, and we'll talk about the effect on the accessories. The tensioner ensures sufficient tension to power the accessories. As the tensioner wears, the belt can slip at the accessories, creating noise, excessive heat at the accessory pulleys, and reduce accessory performance. Now, let's look at the potential problems from belt misalignment. As the belt runs through the accessory belt drive system, all of the pulleys should be in alignment. A tensioner will cycle 1 billion times over 100,000 miles, causing the tensioner pivot bushing to wear. When the pivot bushing wears, the tensioner arm can move out of alignment. This causes the belt to run uphill on the pulley, damaging the belt and causing noise. The system can only tolerate 1 degree of misalignment. For each degree over that, 30 degrees of heat is generated for the belt and accessory bearings, leading to accessory failure. A simple inspection of the belt will not reveal the condition of the damper. Let's look at the effect of a failed damper on the upstream accessory. The damping mechanism is critical to controlling vibration and power fluctuations. As the damper wears, it can no longer effectively limit tensioner arm movement. The belt then slaps against the next accessory, quite literally hammering it to death. Eventually, the accessory will fail prematurely. It makes sense that the belt and pulley must mate properly in order to provide the necessary friction to assure proper accessory function. With modern EPDM belts, it's hard to visually determine when the belt is worn to the point it will affect proper belt-pulley mating. A new belt mates tightly with the pulleys, creating a belt-pulley interface, providing necessary traction while leaving a channel to evacuate water and other debris. The belt loses material with normal wear. With just 5% belt wear, the belt will not mate properly with the pulley, losing traction in the ridges. The belt just rides over the pulley, wandering and slipping over the top instead of transferring power. The evacuation channel gets larger as the belt wears, allowing water to get between the pulley and the belt, pushing up on the belt, causing it to hydroplane on the pulley. Each accessory powered by the ABDS has its own job to do and relies on a smooth and steady source of drive power. When the ABD system is working properly, all accessories are running as they should. The alternator, as an example, will be spinning at the design speed, creating electricity to power the vehicle and recharge the battery. As the belt slips, all of the accessories operate at a diminished output. The amount of electricity produced by the alternator, for instance, will fluctuate with belt slip. This may lead the motorist to conclude that they have a bad battery or alternator, when the problem is actually a worn belt or tensioner. The check engine light may even come on with an unrelated trouble code. The accessories are inefficient and their life will be shortened by the additional stress placed on them. As you can see, the effect of a worn tensioner can be very damaging. Identifying tensioner issues require more than a simple inspection of the belt. And remember, the service life of the tensioner is the same as that of the belt itself. They should be replaced together.